Well, howdy, physics sleuths and inquisitive souls. Welcome to Dynamic Gravity. So, just want to give a quick update on some things going on, the state of dynamic gravity. Number one, it's probably my last video for a while. I'm actually abandoning my career in America and relocating all the way around the world as far as I can get to Asia, probably Thailand. Looks to be the case. Getting the visa now, hopefully. Mainly because I feel, I scored in my last video, my ones I made earlier, you can tell. I kind of believe that, we're in the middle of the tribulation and it's all about to go pop from the Armageddon very soon. So I'm getting out. Peace. Try to save as many as I could. Good luck with the rest. You're going to need it. Also, the best method that I've devised thus far that I've been working on the last year and a half, at least the last year, so far has been a failure. I'm kind of bummed about that. But I still believe adamantly that this is the path. This is the right rabbit hole to be in if you want to create anti-gravity. It's just a matter of tinkering with the variables until you get a situation that's conducive to do so. So I'm going to continue to perform my experiments. Let me see. I will see if I can't post it right now for you. See if it works. Hopefully that worked. But as you can see, that experiment looks like it's on my kitchen table, and it is. That's what I have to work with. But the way it works is I am using plasma in the form of a rarefied gas. Like this is a rarefied neon in a glass tube. And when you put it near an electrical field very strongly, like a Tesla coil, that extra energy that's bleeding off in the electric field all around it gets utilized by the gas, and it excites it. What basically happens is that the electron in orbit around the proton absorbs that energy and goes to a higher state, or even may leave the proton's orbit altogether and just have it like a free radical proton. Both can happen depending on how strong the field is and what you're doing and what source you're using of gas and everything else. But this is pretty much the method of how CERN makes their protons for the Large Hadron Collider. But yeah, so the electric field excites this electron, strips it off, or whatever, and then as it rejoins, because it wants to be in a more stable position, it will emit photons, lots of photons, and so you see here's hydrogen was not lighting up. This is probably the best one to use, I would think. But most any gas will do this. They sell noble gases. I guess they do it the best. But any gas will do this in an electric field. It's just that normally this doesn't happen in an environment such as atmospheric pressure, because there's so much pressure on the molecules and pushing each other that the amount of energy it takes to actually strip that electron away or excite it goes up by quite a bit, enough that, it becomes impractical. But if you have the gas in a partially evacuated tube, now the amount of energy it takes to do that is much less. So now you can get the whole tube to light up with plasma, and it'll have different colors according to what gas it is. Like I say, though, I believe hydrogen is definitely the best for this. Because if you strip away this electron, what do you got left? You got just a proton. And if there's one thing you need to know about dynamic gravity, the proton is the source of gravity. The electron is the source of, when you move electrons or concentrate electrons, you get electric field, which creates a magnetic field. All right. And a magnetic field, it looks like it pretty much is a gravitational field that only affects conductive materials, like metals and whatnot, electrically conductive materials. But if you could do the same, according to dynamic gravity, to the proton, you would then be able to generate gravity. The problem with this is that it's so easy for us to move electrons around because, we'll have atoms that have like a valence electron shell that, can accommodate one, and the bunch that have a bunch extra, and just put a little energy in that system, and it becomes unstable, and the electron just, just slide along, the wire, almost like balls being pushed through a tube is the analogy they taught us back in electronic school back in the day. But if you could do the same to protons, if you could move protons as easily as you could electrons, well, now, according to dynamic gravity's math, you would be generating a gravitational field, possibly a gravimetric field. If you want to go back and see the episode on that. So it's definitely, gravity is 100% very similar. It's the sister force to electricity, is what it is. The sister or the sister is the electron, and the brother is the proton, whatever you want to think of it. They're definitely related though. And so my goal of doing this is to, of course, have hydrogen, probably the best. It might be possible that other gases could do it, but we're going to put this in a electric field, right? And this electric field is going to give energy to the electron. The electron loves to absorb it because it's in the outer shell of the proton. So any energy, like an electromagnetic energy you send at an atom, is going to first get absorbed by the electron because it's around the atom. But like I said, we have this electron. Man, what is this doing? Okay, cool. Why are you doing that? Okay. And this electric field, let's say, excites this electron and, makes them go off over here somewhere else, right? So now what I'm trying to do is, if I'm right and dynamic gravity is correct, then virtual photons are the carrier particle for gravity. So now I'm going to expose this to another field that's a magnetic field, mainly like a magnetic beam. That is what I'm trying to do. Is why I have two magnets that are, two neodymium magnets that are taped up at a distance with a spacer in between. And, normally when you have a magnet, the field, is going to go out like this, with like this being north and this being south pole, we'll say, right? So if you put them close enough together, though, magnets will interfere and alter magnetic field lines. So you can have it to where there are magnetic field lines that are going straight between these two magnets like a beam, and then they will start bleeding off into this sort of dynamic with the fields. This is the magnetic fields coming out. So you can create a beam of virtual photons that are produced by electrons, unfortunately, is the bummer of it all. And then you have your plasma in between this, right? It's what my experiment is doing. It's what I've been doing. And I've been trying to, have my plasma just be purely as much protons as possible. And then shooting this beam of virtual photons from two magnets around it. And I'm hoping that the virtual photons, as they're coming up on the proton, will be absorbed by the proton. And then re-emit it as the virtual photon, or convert it and then re-emit it as a virtual photon of, say, a gravity photon, a virtual photon, instead of a magnetic virtual photon. So instead of having a virtual photon facilitated and created by electrons, I'm trying to see if I can get the proton to convert that into a virtual photon that it will shoot out as a gravitational virtual photon, a graviton, whatever you want to call it. The problem is I'm shooting these negative ultimately charged entities, these virtual photons, these negative charged photons, at a positive entity and hoping that it will absorb them and flip the polarity and make them positive. But I don't know if this is even possible. This might not be a valid method to do it. I might have to stimulate the proton somehow, or give it additional energy in some form. Maybe I don't know, with like lasers or electricity, or I don't know, something to make it more conducive to convert it into the opposite polarity. And I gotta hope too that these electrons just floating around this plasma aren't going to suck up the the magnetic virtual photons and then just re-emit them as more magnetic virtual photons. You know what I mean? Before they even get to the proton. There's a lot of problems with this method. This is why I've redesigned this experiment like 5 different times, and as of right now, using kind of like a thread for like a torsion balance sort of way, I think I'm down to about 1,000th of a gram that I would be able to detect if they're any force. And I really, it's at the point where I can't tell because I mean, the experiment needs to be done in a vacuum, because any air pressure at all at this, range is going to trigger your apparatus. And that's where I'm at. I've gotten to the point where I cannot go any further down in accuracy unless I do this in a vacuum. And I did buy a vacuum chamber to do a reverse polarity test of CERN's finding recently of the Alpha G experiment. They claim that, anti-gravity and anti-hydrogen, atom is affected by gravity more so than it's not, but it's still not. And so I'm like, all right, cool. So technically, if I just use regular protium, the opposite of what you used, I should have flipped results in my chamber, if your math is correct. Otherwise, you're bullshit and you know what you're doing. Unfortunately, the problem is I spent a lot of money on this hydrogen detecting tape, and it looks like it doesn't have the precision I need to really do this, unfortunately. It sucks being poor and broke, trying to do scientific experiments to revolutionize the world, but it is what it is. Well, so that is the state of what's been going on so far. That what I've been working on the last few months, especially trying to redesign this experiment and make it more and more precise. And I've gotten to the point now where I can't make it more precise unless I'm in a vacuum chamber. And ultimately the vacuum, the reason this rarefied gas, like I said, it only works if it's in like a partial vacuum. So it's not a complete vacuum, but it's a lot of vacuum. It's like 95% vacuum. It's up there. Maybe 99%. It's up there. So there's like, only 1% of the gas in there that there would be at normal atmospheric pressure, which means that when I'm lighting it up into a plasma, whatever effect I'm going to get is only going to be 1% as strong as what it would be at atmospheric pressure. And to really get a strong effect, I might have it really, really pressurized, which means now the amount of electricity I need to turn it to a plasma state is going to be an incredible amount. But we know Bob Lazar says that the craft that he worked on produced like gigawatts of electricity. He said it pretty much produced about as much as Hoover Dam, give or take, maybe a little more. So the craft need a lot of electricity to generate gravity, a lot. And I think because, to play around with protons, I mean, first you have to strip away all these electrons, and then you got to control it, and then you got to bombard it with more energy, and it takes a lot of energy. There's no doubt about it. It's going to take a lot, and I don't think I have enough of my little kitchen top apparatus to do it. I was hoping I could at least see some sort of visible effect was all I was going for, but so far, nada. I'm going to keep playing with it, keep tinkering. That's what I do. And hopefully I will see something that looks funny to me. And that's the best way, I think, to make gravity. The only other way I could think of right now is if you were to have like an antenna of some sort. Because you got to remember, we can shoot photons out easily. We can make like X-rays, shoot out X-rays, lasers, shoot out light, any frequency, whatever. Radio waves, infrared waves. I mean, we can shoot out pretty much any spectrum of light we want until we start getting to the really, really, really low ones, like where it starts getting to negative hertz in the virtual photonic range. As I've said in other videos, I believe it works. And the size of an antenna you would need to create a photon in that order of magnitude, man, I mean, you're looking at essentially something that's like hundreds of miles long, So there's definitely going to be tricks to shrink that down. That might be a possible solution, but I'm not really a big engineering electrical antenna guy, so I'm not really the guy to tackle that. I really need some help from a real true electrical engineer that knows all about antennas and frequencies and catching them and sending them and all that stuff. I know a lot, but I don't think I'm on the level to start creating my own apparatus to create gravity waves through that method. But plasma, I still feel pretty confident about this. I really think that the first way we're going to be able to generate anti-gravity in some sort measurably is going to be with some method like this, where we're just basically getting concentrated protons somehow, like plasma or whatever. And then with those protons, we are pumping energy into them, exciting them, and making them pump out gravity waves. Unfortunately, it's harder than I was hoping, isn't it always? My final message to you today, because it's going to be my last broadcast probably for quite some time, I'm going to show you the math that I've been working on recently. I've worked out all the math for dynamic gravity a while ago, like over a year ago, is when I officially got everything kind of sorted out. Um, Here is, pretty much my spreadsheet that I created, um, you know, with a good friend of mine, um, that kind of has the summation of all my math. I've got formulas. Yeah, here's all my formulas right here. Well, I had made an error when I published my paper for peer review. I was throwing out, completely creating this entire frontier of science for gravity as we know it as I go. And unfortunately, I misstepped one place. I forgot that when I was doing my calculations to work out within the galaxy for like dark matter, my dark energy math is still totally fine. I can explain that perfectly fine. All dark energy effects, we can work that out. That's not a problem. Dark matter is a little more complicated, though, because the math wasn't working out perfectly well, or to a degree that I called satisfactory. But I knew there were plenty of variables in place that could to manipulate. They could, bring us there eventually. If I just had a little help, working on this stuff, so it'd make these stupid errors. Well, one of the ones that I learned is this is the formula for Newton's gravity, right? No, my bad. That's Newton's equilibrium. Here's Newton's formula right here. I was just straight up using Newton's basic formula. I was not using the altered form of it that I created, which was more accurate according to dynamic gravity, which is, Newton's formula is, I guess we'll do it. Yeah, it's basically G times, mass 1 times mass 2 divided by r squared. But remember, according to dynamic gravity, G is not constant. G is a property of mass, depending on the density of that. It's not a universal constant. It depends on the source that you're utilizing, is what it basically comes down to. And most all matter is going to pretty much have roughly about the same G until you start getting into the super celestial category, is where things really start getting different and haywire and in a whole different realm. And super celestials like neutron stars, black holes, these sorts of things. And so when I change G, like this is what G normally is, right? So this right here is the math that we have calculating for how much force of Newton's the galactic core we have here in the Milky Way is pulling on a star the size of the sun, the same attributes of the sun, all the way out into the outer rim of the galaxy, right? And as you can see, it's about 3 to the 5th power, okay? And to show you how much force is on the sun, from the galactic black core, here it is right here. Well, actually, it would be less than that. My bad. It would be far less than that because this is the different thing. So yeah, this is the first sun is in the outer rim, right? Well, the problem is 3 to the 5th power sounds like a lot of newtons, but here's a centrifugal force I worked out for these bodies, and for the outer rim, it's actually going to be 2.7 to the 20th power. So you can see we are 15 orders of magnitude too small to have enough gravity to keep that bad boy in the galaxy like we know it's going to be, because it is. So there has to be enough gravity pulling on that to keep it in the galaxy. This is the answer that Newton and Einstein give you, is 3 to the 5th, all right? They're about the same, almost identical. The answer I give when I take big G for the mass 2, which is for the galactic black hole, and change it to the variable that I think where the math starts to add up perfectly is, or not perfectly, but where it starts to make sense is about 10 orders of magnitudes different, to where instead of 6 to the minus 11, it's just 6.6. And if we plug in Newton's new equation with this, a funny thing happens, right? We get 3 to the 16th, right? Well, we need 2.6 to the 20th. So we're still short a little bit. There's still some other forces at play going on here. And I believe that is the repulsionary force going on, kind of the dark energy force, if you want to say, within the galaxy, of the stars themselves pushing themselves apart. The amount of energy that they have pushing is definitely not enough for equilibrium. But with the centrifugal force included, it should be. That would be a hell of a lot of math to do, and I don't think I'm the person to do that. I'm not really a math whiz. I know it seems like it sometimes, but I am what I am. But so with my math, we get much closer, 3 to the 16th, right? Now here's the funny thing. The sun, okay, with Newton's math, it's like still like, I don't know, 3 to the 10th or some stupid thing. Still like way, way less than we need. With my math, we get, we need 4.2 to the 20th power and centrifugal force to be working on there. With my math, we get like 1.2 to the 17th. So once again, we are about 3 orders of magnitude too small, which is way better than 15. Way better than 15. Using my math, using Einstein's math, you are this far away from your target, all right? Using my math, you're about this far away from your target. Just saying. Still think Einstein's the shit? I don't. He was a great mathematician, but as a physicist and a theorist, he was garbage. He sucked. He was the worst. But as a mathematician, he's pretty good. If you take away the fact that he needed like 6 other people to do his math for him, to help him out, make it 3D, add the metrics, all this and that, tensors, because he couldn't do it on his own. But I'm not hating. Einstein is by far a greater mathematician than I will ever be. But when it comes to physicists, he sucks. He's trash. And if you don't know that, you haven't read enough books yet. So the funny thing is, I see is the force, a centrifugal force working out for our sun is 4.2 to the 20th, versus if it was an outer rim is 2.6 to the 20th. It's almost identical. It doesn't really go down that much. I mean, it's pretty similar. So it's crazy that we need to have a force of gravity that is actually going to stay stagnant out all the way out that way, which is odd. But yet, if you look at the math, mine does exactly that. Mine drops one order of magnitude. Sorry, drained rim, just getting blown up in Iraq. 1 order of magnitude and going out from our sun to the outer rim, which I think is pretty good. I think that's pretty good. So, all I can say is this is the state of my math where I'm at right now. It's pretty much done. All that needs to be done really is to know the values for the galactic black holes everywhere we can and just start calculating them and seeing how big they would need to be to produce the amount of anti-gravity or dark energy, whatever you want to call it, to make the universe the shape it is. And if you get a number that's pretty close to what my math says it is, I think at that point I'm vindicated. Because Einstein's is not. 100% Einstein's math is nowhere close enough good there. Also, I've been looking into desperately trying to get some lead and iron balls forged to do a Cavendish experiment to test the actual gravitational constant for both lead and some other, dense metal, and see if the two add up. I know it's not an easy experiment to do. Well, it would be a super easy experiment to do if I had, a proper lab and proper resources, but, kitchen counter. I do what I do. It's not easy, but I think I would definitely be able to prove that the two are 100% not having the same gravitational constant. It is what it is. I'm working on things. I'm trying to make, gravitation, or at least trying to find out if dynamic gravity is truly the one-all, be-all theory in physics that explains everything, like I think it does. There's really no evidence against dynamic gravity, except for, of course, CERN's latest experiment, Alpha G, where they insinuate that anti-gravity is affected by, or anti-mass. What is it? Oh, I can't even think right now. Anyways, antimatter is affected by gravity the same way matter is, which is completely impossible, according to my theory, if antimatter truly is the exact polar opposite of matter and everything else is the same. Now, it's possible there could be some differences with antimatter than matter that don't behave in this manner that could cause this, but if that were true, then all hopes of vindicating my theory or proving my theory are really shot in the foot for a long, long time, like hundreds of years. But yeah, I think eventually someone's going to be able to test whether like a simple positron is affected by gravity or not eventually. And when they do, I think they're going to find results. They're going to not prove Einstein and prove dynamic gravity. Hopefully that day will come soon. If not, Armageddon's probably coming soon. I hope y'all are ready. Stay vigilant, and I hope you guys have a good day and everything works out for you. And whenever I have something of value, I will post again. Until then, adios, muchachos. Actually, I just wanted to put in one post note here. This guy gives me hope, but yet he doesn't. I came across this guy's channel a while ago, and here he's claiming that when he was spinning this thing up, this magnetic array, he felt this pulling on his force, this pulling force on his face. And that he thought was like some sort of magnetic field pulling away charges from him. But if it truly was, as he says, this is exactly what I've been trying to, the apparatus I've been trying to create to generate gravity, right? Like he is, trying to do all sorts of different things with, this plasma and magnetic fields that he's creating, like trying to do fusion. And now this latest thing is trying to create a device that, will help heal stuff. I don't know about all this, but I do know this. His engineering on plasma and magnetic fields is beyond my mind right now, what I can do. So I'm really interested in his research, but unfortunately, I reached out to him and just to see if he wanted to, do some tests on his thing to see if maybe it was a gravitational force, not a magnetic one. From this, I know I actually saw magnetic forces from my apparatus that I was doing. I was getting all sorts of forces coming out of it, but it appeared to be just magnetic in nature to me, not gravitational. So I do think I'm in the right rabbit hole. I'm just not in the right burrow. We'll find out. And I was really hoping this guy would work with me because he claims to have, succeeded at things that I'm trying to succeed at that he just doesn't understand. Unfortunately, though, he says he doesn't want to work with anybody. He's a lone wolf. He collabs. The glory is all his or none at all. it is what it is. This is the state of the world. But I just want to let you know, maybe he's on to something, maybe not. I don't know. Time tells no lies. We'll find out in the end, boys and girls. Adios.
Like, subscribe, submit.